continue that. Then we will do some questions based on the applications of Jasola. So any doubt in the last class? Please ask. So here we can see we were discussing about magnetic field due to infinite wire, right? So we have discussed the general formula like this. We have seen the general formula. We have found the direction, and this was the general formula for magnetic field due to at point P due to finite wire having angle theta 1 and theta 2. So the formula was mu naught I by 4 pi r sin theta 1 plus sin theta 2. Okay. So we have generalized for infinite wire. Theta 1 will be 90, theta 2 will be 90, and magnetic field will be mu naught I by 2 pi r. Continuing to that, let us see if the wire is infinite and it is of, suppose this wire is infinite, but we have to find magnetic field at a point which is at one end. Suppose we have to find magnetic field here. This point is P and the wire is infinite and the current in the wire is I. And let us suppose this distance is R. So we have to find here magnetic field due to this wire at this point P. Obviously, the direction of magnetic field will be inward, and we know the general formula mu naught I by 4 pi r sin theta 1 plus sin theta 2. Here we can see that theta 1 is, what is the value of theta 1? 90 degree, and theta 2 is 0 degree. So from here we will get magnetic field at point P as mu naught by I by 4 pi r and sin 90 degree plus sin 0 degree. So we will get the value of field as mu naught I by 4 pi r. If you compare with the previous result, it is just half of that. Here you can see for wire in both the direction, the field was mu naught I by 2 pi r. But if the wire is only in one direction, half of the wire, magnetic field also becomes half. Got it? So using this, we can find magnetic field due to number of cases by forming the value of theta 1 and theta 2. Understood? So based on this, we will do some questions of NEET based on Biot-Savart law. So we have done the question based on magnetic field motion of charge particle in magnetic field. Now let us see this question number 30. See this question number 30, you can easily tell the answer. So solve this question number 30. So what is the answer? Very easy. Basically, this is R square and this is 4 pi. Check your formula. Yes, correct answer is B, mu naught I by 4 pi, ideal cross R by R cube. Very simple. So this is directly based on Biot law. Let us see some more questions if there. Now see this question number 46. Question number 46. What is the answer you are getting? C. So very simple formula. These are infinite wires. So we have to apply the formula of magnetic field due to infinite wire. We know that magnetic field due to infinite wire mu naught I by 2 pi d. So here, suppose this wire is 1, this wire is 2. So B1 is mu naught I by 2 pi and mu naught I1 by 2 pi. D is half 2.5. So mu naught by 2 pi. We will take common. I1 is 5 by 2.5. And what will be its direction? What is the direction of V1 at point P? Correct. It should be inward. And similarly, we will calculate B2. So to calculate B2, 1 second. So here again we will calculate B2. So B2 we will get as like B2 is mu naught I2 by 2 pi D. So we will get mu naught by 2 pi. I2 की value 2.5 and D is again 2.5. What is the direction of this? B2? Yes, correct. It is outward. So now you can see B1 is greater. So we will find the net field. How we will find the net field? By subtracting. So B will be equal to B1 minus B2. So we will get mu naught by 2 pi. And it is 5 by 2.5. It means 50. No, not sorry, 50, not so 50. It will be 20 minus 1. So we will get as It will be equal to mu naught by 2 pi into 19. How it is 19 coming? Mu naught by 2 pi d. So it is 2.5, 2.5, current is 2.5 and current is 5 minus 5 by 2.5. Oh, it should be 2, not 20. It should be 2, right? This should be 2. So now we will get mu naught by 2 pi. So this is mu naught by 2 pi. Yes, the correct answer is C. All right. So this is how we can calculate magnetic field. Now we have some special cases like circular wires. So in some cases we have to find magnetic field due to circular wires. So we will see those cases. Circular wires. Circular wires, what we have to do? Suppose we have a circular wire like this and current is flowing anti-clockwise. So we have to find magnetic field at the center. So still we can apply Biot-Savart law. Suppose we have to find magnetic field at point P. So we can find the magnetic field using Biot-Savart law. For that, what we have to do? We can, to find the magnetic field using Biot-Savart law, we will first consider a element of the wire. Suppose the element is of length dl and its distance will be like this and dl will be along this. So here theta will be 90 degree, right? And what will be the direction of magnetic field? Due to this current element dl, it should be, if you will do dl cross, dl is in horizontal direction, it will be outward, right? The magnetic field will be outward. So we will calculate dB due to this element, that is mu naught I by 4 pi I dl sine 90 degree by r square. So we will get it as mu naught I by 4 pi r square I dl. Not all the field will the field will be in this direction, right? The magnetic field will be vertically upward like this. Have you understood the direction? Your magnetic field will be vertically upward. So to find the total field, what you have to do? We have to integrate dB. So we will get mu naught I dl by 4 pi r square. So all are constant. R is also constant. So integrate this. So we'll get mu naught I by 4 pi r square, and this is basically total length. So total length of the circular wire will be 2 pi r. So we'll get it as mu naught I by 2r. Understood it? So magnetic field at the center of a circular wire is mu naught I by 2r. Understood this one? All right. Sometimes we have to find the magnetic field on the axis of a circular wire. Suppose we have a circular wire like this, and we have to find the magnetic field at the axial point like this. Suppose this point is P and current flowing like this. So, and suppose radius of the wire is A, and suppose distance is R. So I'm not going into derivations. The magnet, I will write directly the formula of magnetic field. It will be mu naught I by n mu naught n I A square by 2 A square plus R square to the power 3 by 2. This is the formula for magnetic field due to the circular ring at point P. Mu naught n I A square by 2 R square plus A square 3 by 2. So, and the direction will be like current. If current is anti-clockwise, the direction of magnetic field will be away from the ring. Understood? So this is a formula which we would use directly, and from this formula you can also find the magnetic field and the center. At the center, what you can put? You can put r equal to 0. So you will get BO will be equal to mu naught I in here. N is number of loops. N is number of loops. So for one ring, N will be 1. So mu naught I A square by 2 A cube. So we will get same formula mu naught I by 2A. Got it? So this is the magnetic field due to a circular ring on its axis. Understood this formula? All right. So based on this, let us do some more questions. So let us do this question number 31. Let us do this question number 31. NEET 2019 question. All right, let us do this question. It shows, it says a straight conductor carrying current I splits into two parts as shown in the figure. The radius of the circular loop is R. The total magnetic field at the center P of the loop is. So we have to find the magnetic field at the center P. So basically, here what happens, we have to find the magnetic field at the center, right? So the question here is that the current is splitted at this point. Current is splitted in two parts. So we have to find the relation between I1, I2 and I. Then our task will be easy. Now, what happens? From the diagram, we can say that I is equal to I1 plus I2, right? This we can say. And we know that I is inversely proportional to resistance, right? I is inversely proportional to resistance. More is the resistance, lesser is the current. So from the given diagram, we can see that I1 by I2 will be equal to R2 by R1, right? And R2, and we know that resistance of a wire is proportional to length. So it will be L2 by L1. Suppose this length is L2 and this length is L1. And also we know that length is directly proportional to angle. Theta is L by R. So length is directly proportional to angle. So from here we can say that L2 means theta 2 upon theta 1. The angle. Suppose this. And what is the value of theta 2? This is the angle made by this portion. So theta 2 is 90 degree. Upon theta 1 will be 270 degree. So it will be 1 by 3. So from here we can say that I2 is 3I1. I2 is 3I1 since resistance of L2 is less. Now we will put in the given formula. So from there I can write I1, I is equal to I1 and I2 is 3I1. So I can write 4I1 is equal to I. So from here we will get I1 is equal to I by 4 and I2 will be 3I1. This means 3I by 4. So we calculated I1 and I2. Now our task is easy. If you see the magnetic field due to these portions will be 0, right? These will not contribute to any magnetic field since they are intersecting at the center. They are a straight point. We know that we have already seen that magnetic field. Suppose we have a wire and magnetic field at this point is always 0. If the point lies just in the line of the current. So here net magnetic field will be due to I1 and I2 and both are in same direction, right? Both are in same direction. So we can directly say that B will be equal to B1 plus B2. Check again. Both are in same direction. So B will be equal to B1 plus B2, and we'll put the values. So it will be equal to mu naught I1 by 2 pi r plus mu naught I2 by 2 pi r. So we will get mu naught by 2 pi r I1 plus I2. And if you see here, magnetic field will be outward, and so we'll put the values. And I1, I2 is I, right? Sorry, it should not be 2 pi r. We know that it's 2r, not 2 pi r. So we are getting it as mu naught I by 2 pi r, 2r, right? Mu naught I by 2r is inward. It should not be inward. It should be, oh, sorry. Actually, magnetic field due to both the currents are in opposite direction, right? Magnetic field due to both the currents are in opposite direction. Due to I1, magnetic field is inward. Due to I1, if you see, magnetic field is inward, and due to out I2, magnetic field is outward. So here both are in opposite directions. So we can put it as I2 minus I1, right? I2 minus I1. So the net magnetic field will be calculated by V2 minus V1, right? V2 minus V1. So we'll get it as I2 minus I1. So we will get mu naught I by mu naught by 2R I2 minus I1. So we'll get it as mu naught by 2R. I2 is 3I by 4. 3I by 4. 1 second. Connect the charge. So we will get it as calculate the put the values. So we will get it as I2 is 3I by 4 minus I1 is I by 4. So we will get it as will be equal to mu naught I by 2R into 2I upon 4. So we will get it as mu naught I by 4R, right? Mu naught I by 4R. Mu naught I by 4R or 2R inward. there is some calculation mistake. Let us check. I think not I by 2r, so we'll get the value as we have put the value I2 as 3I by 4, I1 is I by 4. Now we have taken the common, so mu naught I by mu naught by 2r, then we will get 2I by r. So from there we can get mu naught I by 2r and 3I by 2r. I think mu naught I by 4r should be there, right? Let me check from other source. It should be mu naught I by 4r, right? The option D should be mu naught I by 4r. Obviously it will be inward. Obviously it will be outward. Let me check. Please check both of you check calculation. Is there any mistake in calculation? Have both of you checked the calculation? Is it okay? Let us moving to the next question. I will do it again. I will check it. Is there any problem in the option or there is something missing in the calculation? I think the correct option should be mu naught I by 4, right? We are getting mu naught I by 4. And let us see. Meanwhile, we are doing the next question. 9 by 270. This is the ratio of angle, right? If you see, this is the ratio of angle. 9 by 270 is the ratio of angle. And we know that resistance is proportional to length and length is proportional to angle. So let us do the next question. Meanwhile, I will do this question. I will check from other source. So let us do the next question. Meanwhile, I will do this question. So moving to the next question. Now let us see. Solve this question number 32. Solve this question number 32. This is also NEET question. Meanwhile, I will check that question. So solve this question number 32. NEET 2016 question. So both of you try this question. Meanwhile, I will check that question and I will solve that. Have you got any answer? You got B, a long current carrying wire. Steady current is bent into a circular loop of one turn. The magnetic field at the center of the loop is B. If then it is bent into a circular coil of n turns, then the magnetic field at the center of this coil n turn will be. So what happens is, first we have a long wire. A long wire carrying a steady current. Suppose the current in the wire is I, is bent into a circular loop. So first it is bent into a circular loop of one turn. So suppose radius is R. So what is the magnetic field at the center? Mu naught I by 2R. Circular coil of n turns. So here what we have, suppose the length of the wire is L. So here what will happen, 2 pi R will be equal to L. So from here we can find the radius, L upon 2 pi. So B1 will be equal to mu naught, and current here will be same. So mu naught I by 2 into L upon 2 pi, right? So it will be equal to B1 will be equal to, from here we will get B1 equal to mu naught I by L into pi. Now what happened? It is turned into, so in that case 2 pi R dash, when it is bent into a n loops. So what will happen is, in that case 2 pi R dash will be equal to 2 pi R dash into n. Since it is n loop, so 2 pi R dash into L will be n. So from here we will get R dash equal to L upon 2 pi n. Magnetic field will be B dash will be equal to mu naught I, current will remain same, mu naught I by 2 R dash into, we also have to apply by number of turns. So we will get mu naught I and 2 L upon 2 pi n. So we'll get it as mu naught I n square by into pi by L, and so it will be equal to mu naught I pi by L into n square. And what is mu naught I pi by L? B naught, B, right? So it will be B into n square, right? B into n square. So correct option is B. Have you got B? Yes. So correct option is B. Understood? Now coming to the back to this question. Actually here we did a mistake. Can you tell me what is that mistake? Here we did a mistake in the formula. Can you tell me what is that mistake? Here what happens is, I will explain you one more concept before going that question, then we will do that question. We know that magnetic field at the center of a current carrying circular loop carrying current I is B is equal to mu naught I by 2R, right? Now what happens if we want to find the magnetic field in the same section? Suppose we have to find the magnetic field due to a section theta carrying current I, and we have to find the magnetic field due to this section only. So what we will do? We have to apply the unitary method, and due to this section you can find the magnetic field at the center as mu naught I by 2R into the angle divided by 2 pi. So this is the formula for magnetic field due to a arc, circular arc of angle theta. Understood? We cannot write magnetic field due to a circular arc as mu naught I by 2R, which was the mistake in writing the formula in the previous explanation. Understood this one, this formula? If you understood this one, we can easily solve that question. All right, so now coming back to that question, we can solve that. Actually, we have found B is equal to B2 minus B1, right? It was, you see here, B2 minus B1, and B2 was like I2 and I1. I will copy this question again. So now what we can do, we will write the formula. What is the B2? B2 will be mu naught I2 by 2R into theta upon 2 pi, 90 degree upon 360 degree, right? So it will be mu naught I by 2R I2 by into 1 upon 4, and it will be mu naught by 8R. And what is the I2? I2 we have calculated as 3I1, right? 3I1. I2 we have calculated as 3I1. And similarly, we can calculate B1. B1 will be mu naught I1 upon 2R into 270 by 360. So it will be equal to mu naught I by 2R I1 into 3 upon 4, right? So it will also be equal to mu naught I1 by 8R, right? So from here you can see that B1 equal to B2. So net magnetic field will be equal to V1 minus V2 equal to 0. Correct answer is A. Understood? That was so much easy. All right. So this is how we should solve questions based on Jasola and due to circular wires. I will give you some questions based on these concepts in the assignment. Now do the remaining concept. We have 2 or 3 concepts. Let us do first those concepts, and then we will do some questions. So let us do the theory part, some basic theory. I will do the theories quickly. You already have done in the classes. So our main focus is to do questions. The very first is Ampere's law. Ampere's law, we all know that B dot dl, what it says, B dot dl, circulation of magnetic field, suppose we have like different current, like suppose I1 is current like this, I2 is current through a loop, I2 is like this, I3 is downward. So circulation of magnetic field around a loop, what we do, we generally assign a direction of the loop, and we take B dot del is equal to mu naught into net current, I enclosed. So it comes as mu naught into what is net current? Outward current will be taken as positive and like this. So this is a circulation of magnetic field, that is Ampere's law. You already may have understood in your basic lectures. So do you understand this one? B dot dl is mu naught into current enclosed. Have you understood this? How we got B dot dl is equal to this one? All right. So based on that, what is Ampere's law? Based on Ampere's circuit law, we can do number of calculations, like you can find the magnetic field due to infinite wire, which you may already know, that magnetic field at point P is equal to mu naught I by 2 pi r, which we have calculated by Sawat law also. So for infinite wire, we can also find by using Ampere's law. Similarly, the difference lies is if we have suppose we have a thick wire. This was thin wire. Now suppose we have a thick wire. This is the uniqueness for the competition exams. These are not asked up to class 12. Suppose we have a thick wire. So in that case, we can apply Ampere's circuit law to find the magnetic field. And suppose the radius of the thick wire is capital R or A. Suppose radius of this thick wire is A. So now we have two cases. We can have internal point. Suppose internal point is at a distance R, and we can also have external point at a distance R. And suppose current in the thick wire, this is thick wire. We have calculated magnetic field mu naught I by 2 pi r for thin wire. So for outside point, B outside, magnetic field will be same as thin wire, mu naught I by 2 pi r, same formula. But for inside point, the magnetic field will be like this, mu naught I by it will be directly proportional to R, and you can apply Ampere's law to find the magnetic field. So the result you will get is Like you have to find current per unit length, and if you will apply like this, you will get like this: B into 2 pi r will be equal to mu naught into I enclosed I upon 2 pi a square into pi r square. So you will get it like this: mu naught I by pi a square, not pi a square. You will get it as mu naught I r square by a square. So you will get V as mu naught I by 2 pi a square into r. This is the magnetic field at inside point. This is basically, if you see outside, it is B naught outside is inversely proportional to R, but B inside is directly proportional to R. This is the difference due to thin and thick wire. So this is the magnetic field. Due to thick wire, we are having magnetic field at inside points also. Understood this one? Differ? So if you draw a graph for magnetic field due to thick wire, it will be like this. If you draw the B versus R graph, if we draw V versus R graph, so for thin wire and for thick wire, what will happen? For thin wire, it will be like this. It will be like this. B versus R graph. But for thick wire, it will be like this. First, it will go like this, and then it will be like this. So this is the magnetic field due to the graph of B versus R due to thick wire. This will pass from the origin. Not from here. This will pass from the origin. So this is a straight line because B is proportional to R for R less than equal to A, right? And for R greater than equal to A, B is inversely proportional to R. That is why graph is like this. Such graphs are very frequently asked in the NEET exam. You understood this graph? So based on Ampere law, let us do some questions. Then we will go ahead. Let us see this question number 43. Solve the question number 43. This is NEET 2019 question. Are you doing the question? Very good. The same like we have done before, the same diagram which we have to find out. Like this is the same diagram which we have studied. This is also thick wire, a cylindrical wire is also thick wire. So inside we will have the magnetic field. So the correct answer is D. So this was the question based on Ampere circuited law. Such questions are very frequently asked. Now I will give you some questions based on Ampere circuited law as a homework. You can do that. Moving to the next theory, that is force on a current carrying wire. Very easy, we know that. So I will not going to do the theory of solenoid and force on a current carrying wire. That is we all know. So we will do some questions based on that directly, and then we will do galvanometer part. So let us do some questions of solenoid and toroid. Let us do this question number 52. Solve this question number 52 and 53. Solve both the question, very easy question directly based on formula. So do both these questions. Are you doing the question? So you got C. You got D and C, right? Or C. Okay. So very easy. The first question is a long solenoid, 50 turns, length having 100 turns, carries current of this, magnetic field at the center of the solenoid. So we know that magnetic field at the center will be mu naught Ni, and mu naught is 4 pi into 10 power minus 7. N is number of turns per unit length, right? So 100 by 50 into 10 to the power minus 2, and current is 2.5. We'll get it as 4 pi into 10 to the power minus 7 plus 2 minus 1 minus 1 plus 2. Sorry, minus plus 2 and minus 2. Plus 2 and minus 2. So we'll get it as 4 pi into 10 to the power minus 9, right? And length is 50 centimeter, current is this 100 turns. So, and also we have to divide by 5. Divide by 5. No, both should be plus, right? It should not be minus. Both should be plus. Should also be plus. So it will be 2 to 2. 2 and 2 will be cancelled. It should be minus 5. So we'll get it and divided by 5. We will get it 4 by 5 into 3.14. Right? This you might have got, right? Okay. So I will not solve much. So I think you will get 6.28 something. Okay. Now moving to the next question, 53. How much you got? Here we have two toroids, 1 and 2, having turns of this and this. average radii this, and respectively the so here what is that? B is we know that B is equal to mu naught and I upon 2 pi r. So basically here in toroid B is inversely proportional to R average, right? So and also proportional to number of length. So we'll get B1 by B2 as N1 by N2 into R2 by R1. So what is N1? 200 by 100 into what is R2? 20 by R1 is 40. So we'll get it as this 2 will be cancelled out. This 100 will be cancelled out. So we will get 1:1, right? Same. Are you also getting the same answer, 1:1? So in toroid, B is proportional to N and inversely proportional to radius. That is the thing. Understood this one? Have you understood this? Rifat, have you understood how we got 1:1? All right. So this is all for today's class. Then in the next class, we will do some question based on galvanometer and conversion of galvanometer. Then we will wrap up this chapter.